Hi everyone, this is Kannababu. Today we'll discuss about indexes in MongoDB. Generally, indexes are similar in MongoDB are similar like indexes in any other databases, relational database management system. So generally, we already know in MongoDB the data will be stored in the form of collections. Collection is nothing but group of documents. Database is group of collections. Collection is nothing but group of documents. So multiple documents will exist in a single collection. So at the time of fetching the data from the collection, the in order to improve the performance of that particular data, in order to improve the performance, we need to use indexes. Actually, indexes main purpose is to fast accessing of data. Generally, collection is nothing but group of documents. Whenever you try to write any query to fetch the data from the collection, there is a concept of collection scan will be there. Collection scan means scanning the total documents to fetch a specific record. There is a concept of collection scan. Is it clear? Similar like database, also the same problem will be there. If multiple records are there in your table, in order to search a specific record, for example, if there are some 1,000 records are there, some multiple records are there in your table. Is it clear? Some multiple records are there in your table. Now, in order to fetch the data from the collection, actually, if it is a database, in database also the data will be stored in the form of table, which is collection of rows and columns. In SQL, if I write a query, select a star from EMP where E number is equal to 999. If I write this query, so generally what will happen, how this query will execute? Generally it will scan the entire table. Whenever we execute the query, it will scan the entire table to fetch the record, first record, second record, like it will scan all the records. Is it clear? To identify where this record is available, 999. So this concept is called as table scan, scanning the entire table to such a specific record. This is the so the searching time will be more. This is what happening in normal databases like SQL Server, Oracle, MySQL, etc. Coming to MongoDB, in MongoDB the data will be stored in the form of documents. So collection is nothing but group of documents. So here also the same story, same problem will be there. Whenever you try to write any query db dot emps dot find of any specific record or anything if you want to find, it will also scan the entire collection to such a specific record. Here the concept is collection scan. There the concept is table scan. Here the concept is collection scan, scanning the entire table to such a specific record or such a specific document. Generally, index in SQL is similar like index in it is similar like index in a book. If you take a book also having some group of pages will be there. If there is no index in a book, if you consider some 500 pages book, you want to search a specific content in that book or a specific chapter in that book. So it is difficult for you. You need to scan the total book to such a specific record. It will scan the entire. We need to scan manually. We need to search manually in each and every particular page to such a specific content. Did you understand? So the searching time will be more. So instead of that, what to do? Take one. We need to keep the index in a book. The first page in the book will keep what index. What are the main advantage of index means? Main advantage is to access the data fastly. So if index is there, first of all, the person who is reading the book, he will search the index, and he will identify the page number, and then within shortest time, he can identify the document whatever he wants. Similarly, in here also there is a concept called B-tree algorithm. Internally, indexes will use some B-tree algorithm to search a specific record. For example, if 1,000 records are there, what this index will do, it will divide. For example, if I write a query, select start from EMP, where E number is equal to 450. So based on your 450, it will divide your total records into in a different format, something like 1 to 450, and other one is 450 to some remaining documents. And again, it will divide this document to 450 to 750, something like that. And internally, it will follow one B-tree algorithm, 750 to 1000, something like that. So here at the time of searching, what it will do, it will check whether that record is greater than 450 or less than 450. If it is greater than 450, as it is record is less than or equal to 450. Okay, na? So it will don't search the content from this particular documents. Is it clear? With the shortest path identifying the record. That is the main concept of indexes. Indexes main purpose is to fast accessing of data. If multiple documents are existing in a single collection, if you want to access the data fastly, we'll try to apply indexes. Generally, one table can have multiple fields will be there. One collection can have multiple documents, and every document will have multiple fields will be there. Doesn't mean that every person will search based on specific field. So we can apply these indexes on multiple fields also, not only on single field. But mostly the important column based on what item. If you take IRCTC website, the customers will search the train details based on from place and to place, from place as well as to place. If you take Amazon, the customers will search the items based on the product name, or based on price. So a lot of things will be there, but some of the important fields will be there where searching will be done mostly. Most frequently on what data we are trying to search on that particular field only we'll try to apply the indexes. Generally, database means if you simply write select star from EMP or db dot collect EMP start find off means it will bring all the records. Is it clear? Filtration is very important at the time of performing searching operation. Mostly when you perform CRUD operations, insert, update, delete, and select, the most operations frequently will perform is select only. Select operation is only the most frequently used operation. So in MongoDB also you can create indexes and you can work with indexes. So let us see here, indexes support the efficient execution of queries in MongoDB. Without indexes, MongoDB must perform a collection scan, scanning the every document to such a specific record. Is it clear? It will take the query execution will take more time. So the response time will increase. Any application response time must be reduced. If an appropriate index exists for a query, MongoDB can use the index to the limit the number of documents it must inspect. Means, instead of scanning the total collection, maximum try to reduce the search process. That is possible only by using indexes. Indexes are special data structures. Actually, internally indexes will use some data structures to perform the searching. Is it clear? Internally, it will use some B-tree algorithm for the searching process. By default, in MongoDB, every document will have ID column is mandatory. If you're not keeping ID also, at the time of creating the collection, ID will be generated. MongoDB creates a unique index on underscore ID field during the creation of the collection. If you want to manually create any ID, you can create some object ID you can assign, and you can assign some unique ID for each and every document. In order to maintain the uniqueness for each and every document, MongoDB by default it will assign unique index on ID column. Is it clear? So, in short, what is the main advantage of this ID means to avoid the duplicate documents insertion. Generally, in database point of view, you have primary key, unique key also will be there. So, what is the advantage of uniqueness means to avoid the duplicate documents. Each and every document can be uniquely identified by using this ID field. So generally, if you want to create an index, you can create simply db.collection.create index of it will maintain. We can create the index in key and value pair format. So here you see db.collection.create index. This is the field name on which field you are applying, and this is the -1 and 1 means first of all at the time of creating the index you have to tell that you want to arrange the records in ascending order or descending order. One means ascending order, -1 means descending order. Is it? This is the field name and this is the order type. Yes or no? Here you see. For example, in this table you can say have some 5 columns are there, 5 fields are there. Employee ID, employee code, employee name, awards as well as country. Is it clear? So in order to identify employee code is there not you can give index on multiple columns or you can create index on a single column also. Let us see practically one example. Here I create one collection and I insert the records in this collection. Let us see here. So here I create one collection, db.create collection of EMPs. First of all, use EMPDB. I want to use this database. Yes. Now create the collection, db.create collection of EMPs. And I want to insert the records in this collection by using insert menu. Here I inserted. I have not given ID, but our default ID column will come. Employee ID, employee name, salary is. I have given 4 records. And I want to find the employee details. Execute here. So it will display all the employee details along with IDs. As I'm not creating any ID, by default unique ID is assigned for each and every column. Why these many again? I think 2 times I inserted. Sorry. So I will try to delete this database. Just delete, drop database. That's it. Click on delete button, it will automatically delete. Here you can see once again you can execute. And here also once again you can execute. And insert menu also you can execute once again. And here you can use the find method. You can see the records. So anyway, here you can see I want to create an index on EMP ID column. Arrange the EMP ID in ascending order. 1 represents ascending order. -1 represents descending order. Now the syntax is db.emps.create index of EMP ID. Is it clear? And here you can see number indexes before, number indexes after, and how many indexes are created before executing the indexes, how many indexes are there, and after executing how many indexes are there. This is the command actually. db.emps.create index of on which column you want to apply index. You have to mention that field name, and you want to assign either ascending order or descending order that you have to mention. 1 represents ascending, -1 represents descending. Here you see db.collection name dot create index of field name column 1. So here using the create index method, we are creating an index on this field. An index can be created after creating the collection. And 1 represents, this indicates to sort the field values in ascending order. First, this all the employee IDs will be arranged in ascending order and then index will be applied. After applying the index, we got this message we have seen just now. Create collection automatically false. Created collection automatically false. Number indexes before, number indexes after, okay. So what is the first line saying that it will shows how many indexes are there before the command is executed. False means nothing is there. We cannot applied anything. Next, the second line number index before shows how many indexes are there after command is executed. And here okay. This is after command is executed. By default here you can see one. Why you can see one means that is applied an underscore ID. By default every document will have ID column now. It is unique actually. Unique was assigned. Unique index was assigned for that particular ID column. That is the reason you can see by default one. Is it clear? After that we applied index manually for employee ID. Now that's why you can see two. So that's what I'm telling. The number indexes before one indicates the number of field values which were there in the indexes before the command was run. Remember that each collection has ID field, which is also counts as a field value to the index. Since the ID index field is part of the collection, when it is initially created, the value of the number indexes before is 1. Because by default ID is applied a unique index. The number index after 2 indicates that the number of field values which were there in the indexes after the command was run. After the command was run, what happened? One index was applied for on ID, so that is one, and on employee number, that is, so totally 2 indexes are there. If you want to apply create index on multiple fields also you can apply. How to create index on multiple columns means here this is the syntax. Here you can see db.employee.create index of the field name and the value, employee ID column 1 and employee name column 1. So we applied indexes on multiple values. Here square bracket is not required, printing mistake. Okay, no need of the square bracket, I think so. Close the bracket here, flower braces. Did you understand? Creating multiple indexes on single document, single collection. So what the meaning of this here? So this we applied employee ID. So if the user will search based on employee ID, first it will arrange all the documents in ascending order, and then B-tree arrangement will be done, and then searching process will be done. Some users can search the details based on employee name, and based after performing the query only, this searching will be done indexes actually. Based on the user query, if the user wants to search based on employee name, it will search. First arrange all the employee names in ascending order, and then the indexes will be applied, and then the searching will be done fastly. How to find the indexes? If you want to see all the indexes that are available in your documents, there is one command, indexes.getIndexes. Finding an index in MongoDB is done by using getIndexes method. db.emps.getIndexes. If you want, you can see here. If you want to find the indexes, is it clear? Here you can write db.collection emps.getIndexes. You can see indexes, on which column the indexes is applied, ID column, is it clear? And another one is on EMP ID column. You can see the list of indexes that was applied by using this getIndexes method. So how to drop the index? If you want to drop the index, the command is db.emps.drop index of column name. Which column? Because one document indexes can be applied on multiple fields now. Which field you applied the index you want to drop, that field name you have to mention here. Is it clear? Simply can db.collection name dot drop index. It is used to drop the index. This is how you can work with indexes in MongoDB. The main advantage of indexes are fast accessing of data. If you take heavy traffic websites like Facebook, you will search your friends' details based on their name or based on their area or city. So a lot of searching will be there. So millions of terabytes of data will exist. So in order to access the data from that, definitely we need to apply what? Indexes to improve the performance. Is it clear? That's it. For more videos, you can subscribe to my channel. Thank you. Have a nice day.